as well. And we have basically been working with Couchbase for the last 4 years, and I've been working from telco to airlines, to retail and investment banking. So most of you here have already been here yesterday, but practically everyone in this room is using Couchbase without really realizing. So everything from what you're using for your devices, such as LinkedIn, which I presume everyone has an account with them, to your Apple accounts, to, for example, if you're on booking flights, you're more or less have to touch Couchbase without realizing that, because the technologies behind the reservation systems are using Couchbase. For example, Amadeus, which is something that handles about 80% of traffic for airline industries, deals and operates for Couchbase. Just to go through these slides here, in a sense, if you look into where we are, Couchbase is about 380 employees in Couchbase, and as I said, our headquarters is in San Francisco, Mountain View, and we have offices across the globe. And hopefully, with the help of Intricacy, we'll be able to have a presence in Saudi Arabia. So if you look at this, the engagement databases, the thing is, the challenge that we're facing at this present time is that people want quick, responsive, and rich information available. You want to be able to operate either online or offline, and you want to be able to do your operation quite quickly. Now, if you see this red car over here, that's basically Ferrari. What they wanted to do is they wanted to analyze the data in real time. So we on the track F1 Formula 1, they needed to extract that data, be able to replicate that across multiple data centers in more or less real time to be able to analyze what's taking place in the engines. So these cars have thousands of different sensors, and you need to be able to stream those sensors and understand, is the car performing or not. So stuff like this, they looked at different vendors and they've chosen us for that technology. If you also look at the other aspects, anywhere, anytime, you want to be able to operate your data wherever you are in the globe, whether you have network connectivity or not. And again, we have that capability through the mobile devices. So stuff that you see here, look-to-book ratios, browse thing, credit scores, etc. These are putting a lot of constraints on these devices. So we'll talk about today a customer called FICO, which handles about 60% or 65% of global credit cards. So if you use Master or Visa card, the backend systems where they actually detect whether this is a fraudulent activity or not is handled by FICO. And the challenge with them is that with these contactless payments, it became quite a burden on their systems, and they needed a system that can handle that. The problem that they were facing is that they had all the intelligence, all the artificial intelligence, and it's already there. They didn't want to actually take that away. All they wanted is a system that can handle high performance of these transactions. So what they did, they kept their legacy system and they ripped and replaced their underlying data fabric. And that's sometimes you'll see that quite common, where you have very well established algorithms, and what you want to do is you just want the actual data fabric to be a lot more performant. This is a slide that I was showing yesterday. What's happening here, there's a lot of interactions, and there's only one transaction. So you need a system that can handle these processes. So what's happening now, customers are becoming quite sophisticated. There's a lot of different comparison websites. So when you buy something, you won't necessarily actually just go to one vendor. You'll actually do your homework and you'll realize what's out there. And this is causing a lot of problems for a lot of vendors. So if you look at the UK, we have something called Experian, and there used to be a very dominant player in the insurance industry. But now you have comparison websites, for example, compare the market, etc. And these aggregators, they need specific SLAs to be able to process that data. So if Experian can't meet those SLAs, it becomes rank number 3 or number 4. Customers won't look at that. They'll only look at the top 3. So these vendors that used to actually have a dominance are now competing with other vendors out there, and they need to be able to have a very responsive system. To be able to handle that, you have to have an engagement database. What we're having here is that you have analytics and transactional database, but what you really need is a database that can be engaged with the customer. And that's the actual transformation that's happening at the moment. So if you look into this, the platforms and challenges that we're facing is the biggest challenge that for systems to be able to cope is these aspects that we covered yesterday, and as most of you are here, I'll probably skip through this, but it's all about the rigid schema and the performance aspect and then slash of costs. And it says you want to reduce your costs quite dramatically. So here, just to recap what we spoke about yesterday, is that you have systems here which are monolithic, either mainframe or Oracle systems, and they're very difficult to scale out and or even scale up. So you either pay a substantial amount of money to be able to get those performance, or what you want to be able to do is you want to be able to scale out your applications here as well as your data fabric. And today what we'll do, we'll show you the intricacies of how Couchbase is able to scale out on demand. So here, if you look into this system, what happens, you want to be able to scale out your applications here as you do with your data fabric. So if you look at the landscape of systems these days, so here you would, what we'll show you in the next slide, what customers are looking for is this part of their ecosystem where they want an in-memory system, they want high performance, and they'll have their legacy systems in there. If you have a very large ecosystem that's been there for 10, 15 years, you will not be able to actually just replace that overnight. So what you see now in the market is that you have systems here where Couchbase is becoming a very dominant player. You do still have Oracle, you have SAP, etc. But the actual chunk where there's a customer engagement is that's where Couchbase is being put into the system. And as we talked yesterday with Apple and Emirates, what they're doing is that they're taking away their legacy system and chipping away at those systems to actually replace Couchbase. And what you usually would do is that you wouldn't just completely rip out your existing system. You'll look at the low-hanging fruits projects and you'll add those. And gradually, your Couchbase ecosystem will increase and your legacy systems will decrease. So stuff like here, what the differences between relational databases and non-relational databases, because yesterday there was some sort of confusion. What is a NoSQL, what to store, etc. So what it does is that it handles JSON documents. These documents can be either in a binary format or a flat file. And these JSON documents, what they really represent, if you're a relational database developer, you'll be quite familiar with what these are. But what you want to be able to do is store your data in a document. And once you store your data in a document, you want to be able to manipulate and change that document quite easily. So if you look at these traditional systems, you'll be quite familiar with this. It's like if I want to extract information, I'll have to do a join across these two tables. But what you really want to be able to do is to say, well, I don't want to do that anymore. I want to be able to store my data in a file, and then within that file, I want to be able to manipulate it. So for here, if you look into these systems, if you do change anything around these systems, it has a lot of actual processing within there. And what you want to be able to do is you want to say, well, okay, I have a JSON document, I just want to add an attribute to that. And you won't be able to do that in a relational database because if you add a column, etc., you need to ensure that you don't have any referential integrity within that system. And that's what the key objective is behind NoSQL, is that flexibility. Especially with these devices that you have now, the IoT devices, these devices will change and they'll be modified depending on what the actual conditions are, depending on what the business requires. So if these databases are causing a lot of hindrance, you're not going to be able to actually meet those requirements. So you need a system that's able to handle that. So if you look into this, it's nothing scientific, but the tendency is that if you do a POC where you're comparing one system to the other, you'll see that in a JSON document like Couchbase, the performance is quite significant compared to a relational database. So we've seen that multiple times, where we have systems that are dealing with data warehousing, and you put that data, you test it out compared to Couchbase, and we have seen the extent where this will probably take you minutes if it's if you have hundreds of thousands of records, and this will probably take you microseconds to actually respond. So the other aspect here, as we pointed out yesterday, these are some customers. We'll go into more details around that. But we have support systems across the globe. We have from India to Manchester in the UK to San Francisco. So if you raise a support ticket, we have that connectivity. And in there we have different SLAs. For example, if you have a silver, a gold, and platinum. With the platinum, you have very strict SLAs. So if you have a production issue, you raise it up. Someone will be on the call with you, and someone will be able to actually guide you through what the process is. This is just some slides, just to show you the customers that we have within the actual Couchbase. There's a number of them, and most of them you'll be quite familiar with now. These are the actual aspects that Couchbase offers you. In the sense, what's happened, we evolved quite rapidly over the years to ensure that we have all these systems available within Couchbase, one ecosystem where you have the actual data fabric. Once you have a data fabric, you want a mechanism where you're able to actually do a lot of computational tasks onto that. So, for example, I think someone asked about what's the difference between Couchbase, full-text search, and Elasticsearch. So what we've done is our customers have asked us that we have systems that have a large amount of data, and to transfer that data across different systems is quite costly in the sense of bandwidth and also time. And usually it's to do with time. So what you do here is that we've integrated a lot of components. So you're able to plug and play. I want to do a full-text search, so it's Elasticsearch. You're able, that service is able to do that for you. I want to look into the eventing engines. You're able to do that within Couchbase. So if you look into this quite quickly, the actual architecture aspect of things. So we support a number of languages within here. For example, the C, C++, Java, .NET, Ruby, Go. So all the actual languages that most customers are using, we do support. And if there is a language that we don't have here, if there is a need for it, we would integrate that within Couchbase. Other aspects here, something also pointed out to me yesterday, what type of connectors do you have? Because we are a technology that interconnects with a lot of different components, we have a lot of different connectors in there. So if you look at Spark or Kafka, we have that. If you look at Hadoop, we have customers that are using a combination of Hadoop and also Couchbase. The other aspect here, the key thing here, if you look into these aspects, what Couchbase offers you is all these services are partitioned. So in legacy systems, you have all these services in one unit. And what we're offering is that each of these units are separate. So as I said, you can enable a service when you require it and disable it when you don't need it. So if you look into these, the relational databases, and most of you who are developers will be aware that if there's a peak in operation, you're going to have a contention with your servers. So what we've done, we've partitioned all these servers, and these are the requirements from the big providers of tier 1 customers, such as, for example, Apple, Visa, etc., where they ask that the number of data they have and volumes increasing quite dramatically, and they want to be able to use these services quite freely without having that contention. And also here we have search, and also later on in version 6, you'll be able to actually use analytics within that. The thing here, what you're looking at, I mean, lots of customers will say to us, okay, what's the transition from a relational database to NoSQL? The biggest thing that you'll have to, the challenge that you'll face is two things to be successful in Couchbase. And any NoSQL vendor in that sense is the data transformation. You need to be able to transform your data from a database, in the sense of tables, to a NoSQL, in the sense of a JSON document. And that's usually where we actually help customers go through this process, either for us or for our partners, to actually ensure that you understand that transition. And the tendency, what usually happens is that the moment you install Couchbase, you start to use it as a normal relational database, and you don't get the performance. So be aware of that. When you do start to use Couchbase, just be aware your data model does change, in the sense you have to structure it in a slightly different way. But the APIs to actually query the data are still similar to a normal relational database. So this is one of the challenges that you would face. But once you come over that hurdle, it's quite simple. And also, once you actually adopted Couchbase, it becomes like quite a viral thing where a lot of different units will see the success of that and start using it quite a lot. So the thing is that how the components of a JSON document is formed, in particular within Couchbase. The JSON document, you start off with a document. That document could be a JSON file, it could be actually also a binary file. We have seen customers that use these as XML, but then you don't have the capability to actually start to index that data and query that data. The other thing that's quite important is that when you have a document, you need to create an associated key with that, because that key will be actually identify that document. This is classed as a primary key, and then the items within that document is classed as secondary keys. So you can index those items in the secondary key, but the primary key is quite key for that, because what happens with Couchbase, it takes that key, it hashes it, and it puts it in the right component with the bucket, which we'll talk about later on today. So the thing is that in that document has values, and the other thing that's quite important is that Couchbase internally will store metadata associated with that document. And the metadata has a lot of aspects with that, so time to live. So if you're creating a session, website, and you would want that session to last for 20 minutes or 30 minutes, and then it times out. So if any of you are using like Amazon or those retail websites, you have a session, and then if you don't use that session at a particular time, it times out and asks you to log in. So this is quite important, so you don't have to develop those aspects. Couchbase, you can actually set TTL for that, or you can actually have it as for Infinity. By default, it's there for Infinity, but you can set those aspects there. There's other things, such as the CAS operation. So if you're looking to do, so Couchbase uses something you have optimistic locking and pessimistic locking. So with Couchbase, you can adopt either optimistic locking or pessimistic locking. With optimistic locking, it says, well, you know what? I don't want to actually secure that document. I want to be able to use that document, and I'll just compare the previous value to the current value. And if the previous value is similar to the current value, I'll execute my operation. If it's not, then I'll write business logic behind that. Because when you do a transaction, in the sense you lock the document, then that's quite a very heavy pay that you pay for that system. In the sense you freeze it, other operations cannot succeed, and then you have to release that lock. So Couchbase has a CAS operation available within that, and also you have revision IDs within that. So if you are doing, for example, cross-data center replication, and you're looking for the latest revision ID, you can use that. And we'll talk about the ways how Couchbase resolves conflict resolutions. So the other aspect that yesterday they were asking me is that how do you connect? So it's quite simple how you connect to Couchbase. It's as similar to a normal relational database. You want to connect, you establish the connection, you tell it which bucket you want to go to, and then you actually add or remove data from that system. So if you look into this, the first thing that you do, you establish the connection to the Couchbase server, you put the IP address within that. Secondly, what you do, you open the bucket, so you create buckets, and we'll show you a demo today how buckets are created. You know what bucket it is, and this is similar to a database. If you connect to a database, you put the actual table there. And then in there, you create a JSON document, so you'll create a JSON document, you can put any attributes in the JSON document. As you can see, it's quite straightforward. And if you are very interested, you can go to our website. There's a lot of tools out there. So if you're a JSON Java developer, .NET, C++, or Python developer, you'll see how simple it is. You should be able to establish a connection, add the data, and then after that, you can retrieve the document from there. Just ask for the document, and retrieve the document and display it. So it's not very complex at all. You establish the connection, the buckets, and then start operating on the system. So the other thing in Couchbase, the most important thing is here is that you have documents that we talked about earlier on. And in those documents sit in a bucket. And that bucket sits in a cluster. So that's quite a key important thing. So the buckets, if you're not familiar with cloud infrastructures or NoSQL, a bucket is similar to a database or a relational table. And that's the conceptual view of it. You just create it to be able to store data within that. And then that bucket sits within a cluster. And that cluster could be from 3 to hundreds of nodes in that cluster. And what that does, the Couchbase handles that for you. The moment you create that bucket, you set a document, that's it. Couchbase will do the underlying infrastructure behind that. The other thing that is quite important is that what we provide in our infrastructure is a cluster manager. And when we show you the demo, you'll actually see the actual dashboard. This cluster manager is quite important because what that provides you is a mechanism to understand what's happening to your system. So if it's a mission critical application, you want to understand every single operation that takes place from the disk queues to the write queues to the CPU load to RAM and what the actual fill rate and rate rates are. And Couchbase provides over 300 different statistics, and you can see that either through the visual format, through the dashboards within Couchbase, or through the actual REST APIs. If you have monitoring systems that you want to interact with your system, you're able to interact with that with Couchbase to extract those information, and then you can create your business logic to say, if you hit a certain threshold, I want you to add another server, or to actually notify an individual that we're hitting a particular threshold in the system. So the other thing here is that we talked about operations. Now here you can actually, once you hit Couchbase, it does it into the actual write queue and also the persistent disk. Now here you can have two different players within Couchbase. You can do a fire and forget. In a sense, you can put this data into the system and straight away move to the next operation. The other thing is to say, well, no, I want guarantees because it's a very important document. This important document is basically related to finance and revenue, basically generating aspects around that. So what you want to do, you want to say, okay, put into the system, but I want an acknowledgement that that data has replicated and has persisted. The way you do that is quite straightforward in Couchbase. You just set a flag in the APIs. You just say that this document has to basically replicate and it has to persist before I move to the next operation. Now, in certain systems, that if you develop a bucket, and that bucket has to be locked down for every entire transaction. In Couchbase, it has the flexibility to a granular level where it's document by document. So if you have, shall we say, a billion documents, it's not very uncommon. We have customers with 10 billion, 20 billion documents in Couchbase, and only say, for example, 10% of those documents need a full guarantee. Then you can do that during the API when you actually insert data into the system. So if you look into this, what happens here, you put the data, it replicates it, it gives you the acknowledgement, and then also, if you want to persist the data, you can get that. So some customers will say to us, replication is great, but we also want to actually persist. Because if we have a complete outage, we need to be able to actually recover from the actual disk itself. So having said that, I'm aware that most of the slides we have shown yesterday, what I'll try and do now is actually show you a demo of Couchbase and how you can actually benchmark Couchbase. It's straightforward, and when you download Couchbase and install Couchbase server, there are buckets available for you, and you're able to actually test it for yourself. So on this laptop, you can get up to about 50,000 operations a second. In other systems, you can get up to 4 million operations a second. So if I just get out of this system and go into my desktop, so what I've got here, I've got my own cluster, well not cluster, my own, for example, Couchbase installation. So once you install Couchbase, it asks you for some configurations, but what I'll do, I'll just log into the system. So you can see here what I've got here. So when you log into Couchbase, it's quite straightforward. So here what I have something called a default bucket that I created earlier on. And when I do the next demo, I'll show you how you can create a bucket quite straightforward. And also I have a travel sample bucket. And Couchbase has lots of different buckets. So if you want to go through the tutorials and test it out for yourself, there's also lots of different buckets. And what you have here, you have the number of servers. So at the moment, it's only one server, and you'll get a warning message because on a laptop, it requires a free installation of Couchbase because you want to avoid split brainers and you want to ensure that the data is consistent. So here, what it has all the actual different services on there. So as I said to you before, you can actually disable some of these services depending on your requirements. So what I'll do here is that I want to actually look at the statistics of this bucket. So if I go to the statistics, you have lots of different statistics out there. There's loads of them. I mean, you can actually click on these bucket basically icons, and then you have a lot more statistics there. What I want to do here, I want to see how much operations I can get within this laptop. So what I do, I've got a little command, it's called vilify, and that's part of Couchbase. So if you go to Couchbase and just type in your command, so what this does, in a sense, it says connect to the actual node itself. I want you to actually create this amount of documents, but I want the actual read and write ratio to be of this. I want to say 80% reads, 20% writes, or vice versa, or 50-50. And I want to know the number of threads. So I can put up to 4 threads. It probably really will push the system. But put it down to actually 2 to 3 threads. So the moment I click on this, what would happen, you'll see the actual statistics. As I pointed here, at the moment there's no operations taking place. The moment I click on this, what's happened, it starts to actually push the actual operations, and you'll see the spike of operations that you can see here. And what that does is that it starts to show to you, well, I want to benchmark the system. Say, for example, have loads of clients within the system. You can point that out, and you can represent that through a thread, and then it'll tell you how much operations to go through. It tells you all the read-write ratios. There's lots of different statistics available in Couchbase. So as I said, you can see that quite straightforward, is that you've got the Couchbase server, you create a bucket, you just fire a command into there, and you have those number of operations. And these operations that you see here, if you have a monitoring system, all these operations that you see here can be actually captured through the rest of the interfaces within that. So as I said, this can go on forever. Then you've got different, you can look at the dates, the actual months, years, etc. And then if I wanted to stop that, all I do is just do Control-C, stops, kills the number of operations, complete drop. So you can see, you can do that for yourself. It's straightforward and nothing that you need to actually, it's nothing complicated. But in Couchbase, it's all about ensuring that the development is straightforward and not too difficult, because the adoption is very important. You don't want to move from a system you're very comfortable with to a system that's quite a steep learning curve. So if I go back to my presentation, so we talked about the guarantees, etc., that you have in the system. This is another important thing, and we'll talk about this quite extensively, because yesterday when we spoke about, okay, you've got servers, but I mean, in a normal relational database, you can't break down that server into different partitions. It's quite difficult. I mean, you can, but it requires a lot of skill sets. The other thing is that you don't want the application to be handling all these different partitioning. You don't want to have the application say, well, put this data in server number 1, put this data in server number 2, because then you're going to have hotspots. And what you'll do, you'll have systems or nodes that are overloaded compared to systems that are not, or nodes that are not overloaded. You want that to be handled by the Couchbase server, and if you add servers and remove servers, it should automatically handle that for you. So if you go back to this slide, is that the way it works, what happens, it has a bucket, and this bucket is divided into 1024 V buckets, and this is quite important. By default, Couchbase will break down your bucket into 1024 virtual buckets. And then what it does with those virtual buckets, it always creates active data and also replica data. The active data is where the data is being farmed by the application, and the replica data is that if you have an incident in the system where the node goes offline, the replica data will kick in. So if you look into this, for those who are developers and architects, the moment you have a customer, so what happens, you have an application tier here, and then what you do is you create a cluster, and this cluster has 3 nodes. So the thing that you do is in your SDK, with the APIs, the first thing you do is, we pointed out before, in that Java example, you do a connection. Once you establish that connection, it talks to one of the nodes, and you can list either one node or all the nodes in that cluster. Once you establish that connection, it takes a cluster map. That cluster map, all it is just a very light text file, where you're able to extract that information. And then once you've done that, it has a cluster map available at the SDK level. And then what it does is, at the moment you add attributes in the system or document, it hashes that based on the actual document ID. The document ID is a key. Let's say, for example, you had a massive peak in operations, you had 2 more servers. The application will not be affected. The user should not be able to see the actual insertion of 2 servers, and your operations will continue to operate. In Couchbase does that by doing a rebalance across the nodes, and that does it as a back-end process. So if you look at it here, as we discussed yesterday, you have active data, and that active data are on a particular node, and then you have replica data on a different node. But the active data set, if you have a bucket, is shared across the 3 servers that you have in that system. The moment you add, for example, 2 more servers, it automatically shares that information via the data. And again, it doesn't affect the customer. The customer is insulated from that process. But the other thing that was quite important is that in a distributed system, you have a node that fails. And if that node fails, what you want to be able to do is you want to be able to actually get the actual data to continue to operate without basically affecting the application. And what happens, Couchbase has certain SLAs that if they're not met, it will promote the replica to active data. The other topic that we want to show or do a demo as well is cross-data center replication. Now this, in certain technologies, in my experience in different technologies, this is quite a complicated process, because either A, you have to change the application tier, or B, you have to do a lot of configuration on the server. And you want to basically have a data center A, and then data center B. You want to take your data from data center A to data center B, more or less real time. So if you look into this, and we'll go through the demo to explain this to you. So the XDCR, the purpose of this here is that I want to count my mechanism as it was before. I have your cache, and you have your disk, and you have replication. The cache must be replicated 3 times in a particular cluster, in one cluster, and also you can have the actual data set, the active data set. So what you have there, you have 4 copies in the cluster. Now, there is business requirements. You say, I want to copy my data center A, you say Riyadh, to Jeddah, and I want to do that more or less in real time. But all you want to do is just set configuration at this point. You say, look, if I have a different cluster, I know the IP address, replicate this bucket to that bucket in that other data center, and you should automatically handle that for you. And we'll show that in a demo how straightforward and easy to do. And all you need is a cluster in one cloud or region, and then another cluster somewhere else. And it could be even on the same network. And it's quite straightforward, and we'll show that from the demo. So here it just shows you can have different regions, and also here you can have bidirectional, unidirectional chain propagation. And we have seen this quite a lot, the unidirectional and also the bidirectional. The other thing is that we do see this these days, because what happens, you have some organization will say to you, I want data to be active and also replica, and then overnight I want to back that information up somewhere else, just in case we have a disaster. So what happens here, the reason why we have XDCL, one of the reasons is because if a data center goes offline, or you want to do maintenance, and even if you want to do maintenance in Couchbase, you're allowed to have multiple versions of Couchbase coexist in the same cluster. So for example, if you want to do a patch or a maintenance, and you want to move from version 5.1 to version 5.5, you're able to do a rolling upgrade without bringing down your services at all. So some customers will say, okay, well, I want to do a massive change to our cluster, not only the Couchbase server, but also the hardware, etc. So you can bring down a cluster, and the other cluster can take in the operations. Then the other thing that you have in Couchbase is that the conflicts. If you use a bidirectional, in a sense, 2 data centers are active, and you haven't configured it properly, or you say, well, my applications, I can't partition my data for particular users. I want to be able to use conflict resolution APIs. So in Couchbase, you have either the default, basically the revision ID. So who has the highest revision ID would win that conflict, or you look at the actual clocks. Who has the highest timestamp will win that conflict. So what we'll do here, we talked about XDCL. We'll show you how simple it is. So before, earlier on, what I've done is I've created a cluster. Let me just log into this cluster. So what we have something called right scale, and it's based on AWS user services. And what we have here, we have a primary cluster and a secondary cluster. And if I log on to this, so that's, let me just check which one this is. This is the primary cluster data center. So what I'll do, I'll go to the statistics, and then I'll log on to the secondary cluster. So in this, what you'll see here, you have no buckets at all. So this is just the number of servers here. So here I have 3 servers. I have, and these services have practically all the old services you can have in Couchbase. So this is my secondary data center. And also have a primary data center here, where I have an application, a script that's running in the background, doing all these operations. It's pointed out on my laptop. You're able to do quite a significant amount of operations, all these statistics here. But here I have more servers in my primary data center compared to my secondary data center. If I look at these servers I have here, you'll see I've got 5 servers, 3 of them have got data services, and the other ones have index and query services on top of that. But the thing is, what I want to do is I want to look into these statistics here, my data sets here, and what I want to take this information that I get, and the network's not great here, but I want to take this information, any operation that happens here, I want to transfer that data to a secondary data center. So if anything happens to this data center, the secondary data center is able to handle it. So if I go to the actual secondary data center, the first thing I need to do is I need to establish a bucket, because I don't have a bucket here. So I need to create a bucket, and then I basically say what type of configuration it is. And you'll see how simple it is to create a bucket. So click on this. First thing you'll do is you need to give it the bucket a name. So if I call it backup, And then here you state how much RAM you want to give the bucket, what type of flavors do you want to actually have it, as a cache-based bucket, inferior bucket, memcache bucket. And the differences between this and cache-based bucket persists the data to this. Inferior bucket does not persist the data. If you want a complete cache, like Redis, etc., you can have that within cache-based without persisting to disk. And the other things is that you have different configurations here. You can state how much replication you want, what type of conflict resolution you want to establish. And again, as you can see, it's quite straightforward in this. There's nothing that's too challenging. You don't have to actually write a lot of code for it. So what I've done here is that I've established my backup bucket. And I'll just say create a bucket. So what this does, it goes to warm state. It will actually create the bucket. And it gives you a certain amount of time. Now the bucket is established. So now in my secondary data center, I have a bucket available there. The thing is, you'll see there's no statistics because there's nothing pumping any data into that. There's no application hitting that. It's completely at the moment 0. So what I need to do now, I need to say, well, to my primary data center, I want you to start pushing data across to my secondary data center. And these clusters are on different sites. I want you to start pushing the data across. So what I do here is that I say, okay, well, we have lots of different facilities within Couchbase. The first thing I do here, I go to the XTCR. So what it requires for me from the XTCR is quite straightforward. First, I need to establish a connection to the remote site. Also establish that connection. The second thing I need to do is I need to say which bucket I need to connect to and what do I need to do with that. And then within Couchbase, you also have something called filtering. Say, for example, you've got a contract with the KSA and also UK, and your requirement is that any information that deals with KSA citizens cannot be transferred to a different region. Then you have the Couchbase filter, which filters only data that can be sent across the wire. Data that can't be sent across the wire will remain within that cluster. On top of that, you can encrypt the data. So if you want to encrypt it and also filter it, you're able to do that within Couchbase. The first thing I need to do here is I need to actually give it a name of what I want to call it, because you can have one primary data center and a number of different data centers across your ecosystem. So for this one, I've just got to call it XDCR demo. And then I need to get the IP address. So I did this before. I need to get an IP address of one of the servers in the secondary data center. So I already copied that information. So what I'll do, I'll just take that information from here, paste it there, and then it requires the password and the username of the secondary data center, which was admin. I'll put the password in here. If I did that correctly, it should establish the connection. So what it's done now, it hasn't done anything. What it's done is just made a connection, established a connection to the secondary data center. So if you look at the other data center, there's nothing happening at the moment. What will happen is at the moment I do an establishment, I need to say what bucket I need to replicate to which bucket. So at the moment I have a travel sample bucket. And what I do here is straightforward. I just click this. It asks me a few questions. So for here it says, select the bucket, travel sample bucket, and then also the actual which, because you can have a number of connectors from your primary to your secondary. So you can have a data center A, and then you can have data center B, C, and goes all the way to whatever number you want. So you need to state which data center I need to connect to, which I already gave called XCCR demo. And then I need to actually state the actual remote bucket. And if you remember in this other side, what I called it backup. So if you look into this, it's that's my if you remember what I've called it here, I've called it backup. So that's just to show you it's a real world demo. If we go to here and put backup. And then after that, it tells me the version. So if you wanted to do filtering and advanced capabilities in Couchbase, you can do that. But for this purpose of this demo, all I'm going to show you is the replication between the primary and the secondary data center. So if I've done this correctly, what will happen? It will establish the actual connectivity, and it'll start to replicate. So as it's over the wire, it might take a bit of time to actually establish that. So it's established it. It says basically it's running. if I go to my secondary data center here, what you'll see is a massive spike. So if you give some time to actually start to adjust, and what you'll see, you'll start seeing the statistics go across. So what you'll see a massive spike taking place initially, and then here you can state which servers have actually established the connection, and most of them have done the connection. So what you'll see is that here, what it's done here from the primary to the secondary, it has done the statistics. And if you give it some time, because it's not web-based and the network's not very, very clear, you're able to actually see the number of operations that are taking place. And usually what you'll see the number of operations here compared to the actual data center, the primary data center. So what you've seen here, you've seen how simple it is to establish a connection from one primary data center to the secondary data center, and that information that's happening in the primary is replicated in the secondary data center. So as you can see, it's quite a powerful tool. So basically, you can see now in the graphics, what is done from the primary to the secondary is taking data that's in the primary, and any mutation that happens in the primary is pushed across the secondary. And you need these capabilities for mission-critical applications to establish the connectivity and to ensure you have the high availability. So if you kill, for example, your primary data center, the data that you had to that point is available in your secondary data center, and you're able to operate from that. So if I go back to my slides, do you have any questions at this point? If it's okay? Yes. Yes, you can do it through the APIs if you wanted to. So I just did it for a demo because it's easier just to click and basically enter the information. But if you wanted to do it through scripts or APIs, you're able to do that, yes. If you want to do it through REST APIs, you can do that. If you want to do it through scripts, languages, you can do that through Couchbase.
Excuse me. Yeah. I would like to ask about transferring data between clusters depending on demand of the data for performance.
So the question is that you have a primary data center and you want to transfer data to the second data center based on demands. When you say demands, what do you mean by demands? Do you mean the load on one system, or
depending on the hits on the data, on requesting these data.
Okay.
So if you have many requests for these data, they should sit in one data center, right? More than just replicating it everywhere on all clusters.
So you got the capability to say to yourself that what data you want to replicate. So you can have multiple, you can have several buckets in one data center, and you can specify which bucket you want to replicate. And also, if you want to actually filter only a certain amount of data from the primary to secondary, you can actually filter what data replicates across. And if you say to yourself, well, no, I want to actually add more threads, I want to throttle the system, there's a lot of configuration that you can do in your Couchbase to say, I want 40 threads or 50 threads to push the data, or I want you to use this capacity to ensure that the XTCR takes place. So you have those filtering, and I'm not sure if that's addressed what you're asking for.
Partially. Another question about data integrity. In our DBMS, there is a transactional queries in order to ensure multiple inserts, multiple related inserts. So how is it handled with Couchbase document database?
So I think the question is that in relational databases, it handles multiple inserts. So if I've got 10 users using the same document at the same time, is that the question?
No, actually. I'm asking about multiple and related inserts. Let's say the, transactions. Yeah, so how is it handled for with rollback capability?
So with in regards to rollback, with Couchbase, you have internally you have a revision ID within that document. Every time you do an insert, there is a revision ID. Also, Couchbase has atomic operators. So if you want to use atomic operator within that. In regards to actually what you're asking for is ACID transaction. In the sense if you hit this operation, you do this operation, and you want to roll back. In NoSQL, no SQL vendors offer that ACID transactions because it's all about high throughput, low latency. So if you're looking at ACID transactions, what we have customers do is they develop a data model. where they basically mimic a transaction. They have a parent document and child document, and the child document is updated, but the parent document handles the history of that information. So at any one point, if you want to go back, you're able to actually find out what was the actual revision ID from the parent document and what was the last value. But if you're looking at asset transactions, there's no SQL vendor will offer that at this present time.
Thank you.
Okay. So I can ask that question if you want.
Okay. How would I be able to use this with data mining tools like R or Python?
So with data mining is that, I'm not an expert in data mining, but you're looking at colossal amount of data and you want to be able to actually number crunch that information. And with couch-based architecture, it has the capability to actually store the data into actually in memory, so it's not on disk. So if you wanted to actually extract that information quite quickly, you're able to do that. Plus, different algorithms that we have analytics that's going to be launched in version 6, which is going to be the end of the year. And you have other functionalities such as Nickel, full text search, venting. So if you're looking at data mining in the sense you want to read that data, you want to extract that data, then Couchbase provides capabilities where you can index, create secondary indexes. If you're looking for speed and performance, you're able to do that. We have other customers, what they're looking for is that they have data coming in and they're using traditional complex event processing, CEP, and they want to use Couchbase to be able to actually filter that. So if anything, if you're looking at data mining, velocity amount, high volumes of data, what Couchbase can do in that area is to actually give the speed to be able to extract that information and be able to interpret that. Does that answer the question? Okay.
Usually people use specific tools for data mining. Talking about agents, and you want to be able to do things like Amazon, where it says people who bought this also bought this in an online basis. It's basically a data mining problem. So my question is, how does Couchbase lend itself to tools like R?
Yeah. So if you will, when we look at the PayPal architecture, what they're doing is that they're using a combination of data mining tools, such as Hadoop, etc., with Couchbase. Because the thing is that in real time, you can't do a data mining process. Oh, well, customer A has brought this. Let's go do some actual algorithms now and find out and give that information. That's going to take too long. So what PayPal do, which is the architecture, is that they have Couchbase sit right at the front. The data mining has already taken place, the number crunching has already taken place. They extract that information, keep the actual essential crew of that information in Couchbase. So the next operation that comes, there's two threads. One thread goes to Couchbase, giving the historical information of that individual, fire out an advertisement for him. The other thread goes into the Hadoop cluster, where it does that number crunching and analytics, and it extracts that and puts it back into Couchbase. So what they're doing is a more machine learning where they have some data sets, which is quite quick to access. The other data sets where they can have more time to actually analyze it or go into Hadoop. And they have that cycle within the system. So they have two systems. Couchbase sits right at the front. The other system sits at the back. The moment they hit Couchbase, they extract the information that they have about the individual, target that individual with what they have advertised with. Then the other thread goes to the back end where it does all that number crunching. So there's no more questions. So if you look into this, the other aspect that we wanted to cover also is, we mentioned this yesterday, and again, this is quite key information, is that you have systems that have all the services as one unit. And what you want to do, you want to strip those to individual units. So if you look at traditional systems, you have everything in index, query, data. But what you want to be able to do is you want to be able to partition this, depending on the hardware. And that's quite important, especially if you look at the actual containerization is operated. Is to say, I have machines with quite powerful CPUs, I have machines with quite powerful disks, and you want to actually strip those machines based on your requirements. So in Couchbase, it allows you to actually partition your data depending on what hardware you have and be able to actually scale out on that. The other important thing within Couchbase is that it's not quite nickel. And as I pointed out yesterday, you have the power of SQL with the flexible JSON document, and you want that capability to combine as one. So if you look into this, the traditional approach in SQL-like format relational database is that you have select from where, and what you want to be able to do is you want to use that information as your APIs, but you want to go into the system and extract the information. And when you extract the information, you can visualize it in, for example, a JSON document. So what happens here, the moment you actually push that, either through REST APIs or native APIs, it goes to the query service, and that's an independent service within Couchbase. It hits the actual index service, and you can have covering indexes, and what it does, it analyzes the plan. It goes to the index service, extracts the data. If the data you require is an index, you respond back to the client, and if it's not, if it has to go to data services, it goes to make a call to the data services, extracts that information, and then it gives you the results as a JSON document. And that's quite key because as a developer, you don't want to learn another language. You want to be able to actually use this language and get the data that's available in your system. The other thing within Couchbase, we have quite a lot of different APIs. If you're looking at arrays, sums, functions, etc. So we have got extensive APIs within the actual NICL interface. And what we'll do also, which I won't go through these, but there's a lot of APIs. This gives you a flavor of what Couchbase can offer you if you are interested in actually starting to use Couchbase in replacement of your existing systems, whether it's Oracle, SAP, IBM, etc. What we'll do here also, as I said to you, with Couchbase, it gives you those capabilities and it allows you to actually visualize the actual path. So what we have here to actually give you a flavor of it, there are some queries here. And if you download Couchbase Server, you're able to actually just ask it to install the travel sample app, and you can take some of these examples and then you can scheme for yourself. So if I go to the local installation that I have, what I'll do, I should have the travel sample bucket there, and I'll start executing some data. So if you see here, I've got the travel sample bucket, and what you do, if you go to the settings in Couchbase, they'll give you, if you go to the sample buckets, there's a number of different buckets there that you can choose from, and you just select one bucket from there, and it will basically load that for you. But the other thing is that when you load that bucket, what it does is that it has, so it has the query workbench here, and also it has the indexes available for you, searches capabilities. Yeah, so here are the indexes. So automatically, when you actually ask it for the travel sample bucket, it automatically indexes those attributes that it requires for that bucket. But again, if you wanted to actually to create indexes, you're able to do that. So if I go to the query workbench, and this is something that I've done before. So if I go to here, and say I want to extract a simple query from this, take it, put it into this over here. If I execute it, what will happen, it'll go through and give me the JSON document. It's slightly fast. So as I said, it gives you that interface, and then it gives you the actual results back down there. But then the other thing is that some people say, well, I wanted to look at a table. So Couchbase will do its best to actually represent the data in a table. Within a JSON document, you can have multiple attributes, but it'll try and represent that as much as possible. Also, if you wanted to do it in a tree, you'll do that, and most usually you represent the data in a tree in the system. And also the last thing here is that if I wanted to actually visualize the data, did I do the right query? Did you optimize that information? It also gives you that representation of Couchbase. So it's quite a powerful tool, so I would very encourage you to actually look at that. We don't have much time, so what I'll do quite quickly is that I will go to, just to show you this, and then we'll probably stop for the thing. So here, if you wanted to visualize the data in the visualization tool, you're able to actually do that with Couchbase. If you have Tableau, Informatica, you're able to do that. Other aspects here is that you have basically all these capabilities. So what you do with the ODBC JDBC drivers, you connect that to Couchbase using the SDK, and you're able to extract the data and visualize that information. I think we're out of time, but is there any questions on this? I mean, there's a lot of information that we can talk about, and I would encourage you to actually download Couchbase, and hopefully you found this session useful, especially how to actually, how easy it is to use Couchbase from normal querying to XDCR, to actually replicating data across data centers, and to also benchmark your performance in that system. Is there any questions that anyone has? That's a question then.
Hello everyone. So recently I had to make a choice between MongoDB and Couchbase, and I apologize. I choose MongoDB because of the week of documentation or open source documentation of Couchbase. Is it any improvement in this side? So do you want to help more the community edition to be more large, etc.? This is the first thing. And the second thing, at that time, I didn't find a lot of tools, what you have as community edition. You know, so is it, do you have now any new tools to, I don't know, manage databases or clustering or everything?
So, I mean, you're not the first person to say that. It's very common. So what we see in the industry, Mongo's done a good job in penetrating the market and mindsets of people. But what people don't realize is that the moment you start to use Mongo, if you want to put it into production for mission-critical applications to really push the system, for example, if you have Black Friday or Cyber Monday, or you're a financial institute, customers will start off by using Mongo and then realize they can't scale on demand. We have a number of customers that have moved off Mongo. If you look at Viber, for example, they went for a very painful journey where they started off with their own cache, and they started with Mongo. And you can see the YouTube video of the architect saying, we could not scale out with Mongo because in the start they have a lot of basically community developers, they have a lot of marketing, but we couldn't scale out in production. So you're not the first, and I can understand that, and we are improving quite dramatically in the marketing aspect, because what we did, we targeted the architects, and Mongo targeted the developers. And we're actually now basically doing another revamp of that, ensuring that we do cover the documentation, tutorials, etc. We also see, like, for example, Tesco's has started off Mongo, they've got the Couchbase, and there's a number of customers out there, lots of testimonies. So, yes, what you're saying is that the documentation, what we've done now, we've ramped up on the documentation, on the tooling, etc., the marketing aspects, the dev advocates. So that aspect has been addressed. In regards to if you are using for scaling out, you know, with Couchbase, if you do compare it basically apples to apples, and it says, let's push it out, let's add more servers, you'll see the performance of Couchbase because we don't have this concept of master slave. If you want to cache, it's integrated within Couchbase. If you want to do cross data center replication, you have that capability. So if you're looking for enterprise grade performance, then you'll probably, if you are going to production with Mongo, you probably would realize that you'll be probably having some certain issues that you need to actually fix within that. So I think I addressed the first question. Second question in regards to documentation, there's a lot of documentation. I'm not sure when you actually looked at the actual Couchbase site, but you have now through tutorials. There's quite an extensive amount of work that's been done over the year.
And I have another question about licensing, because I remember that at that time, Couchbase gives the old version for the community edition. So the enterprise is a new version. So you have to pay to have the new version. And
so
sometimes that
yeah, so in regards to, sorry, did you finish the question?
Yeah, just for saying that there is a lot of people, they are talking about community edition, have a lot of bugs, etc., and it's resolved in the enterprise edition. This is a little bit bad because people they want to touch the product before going to enterprise edition.
No, that's deliberate. If you look, we adopt more or less the model of Red Hat, because you can have a community edition, you can have an enterprise edition. The purpose of a community edition is that you just use it to test it out. You never go into production with Community Edition. We never advocate that because there are, in the Enterprise Edition, is basically you have security grade performance, you have a lot of stuff that you will not get in the community. So for us, the Community Edition is just for you to test out, to actually play about, see the capabilities within that. The Enterprise Edition is where you go into production and you actually use it in anger. So if you are using the Community Edition in production, that's something that we will not encourage you to do because there are bugs in there. If you're on the Enterprise, you're paying for the Enterprise fixes, etc. The bugs will be fixed in about 3 or 6 months because the primary purpose is to ensure that Enterprise customers gets the best service. So the reason why we have a Community Edition is to give customers the flavor of what Couchbase can offer. But the moment you go into production, you should really be using the Enterprise Edition.
Thank you.
Is there any other question? Okay.
Yes, my question is that if I have multiple documents in different schemas, can they be in one bucket?
I'll answer the question. So this is a very typical question that a lot of customers ask. In relational databases, you have schemas, etc. In Couchbase, if you look at Apple, if you look at Amadeus, all these tier 1 customers, they only have one bucket in their system. And in that bucket, they have multiple different schemas within that. So if you look into if you want to actually have multiple different schemas, we would encourage you to actually have multiple different schemas in the same bucket. So you can actually have that, yes. You're allowed to do that.
Do you have migration tools from other databases to Couch database?
So we do have some migration tools, but we always encourage the customers. The problem is, what they'll do, they'll just take the relational databases because they think they can move from Oracle to SAP or IBM. The concept of having relational and non-relational, there's a big mind difference between the two. So we do have tools to move from Oracle to Couchbase, but we would strongly advise you to say, okay, this is your relational database, because you have to remember, the reason why you created your tables in a particular way is because you're dictated by the principles of relational database, normalizing the data, referential integrity, etc. So when you design that, you design it based on those principles. In NoSQL, for example, in Couchbase, it's more about engagement. How does the customer engage with the actual application? It's no longer how the database dictates it, but it's what the customer wants from this application. So you need to actually create the data model based on that interaction. So what we usually do, we usually help customers, for example, when we stick with Emirates or Sky or Richcard, we sit down with them and ask certain questions. How does a customer interact with that user or that application? And then we design the data documents based on that. But if you wanted to actually migrate the data from one to the other, you could do it, but you're not doing it justice to the application because then you'll still be facing the same problems as you had before, probably with better performance. But to ensure that you have a good system that could evolve over time, you should really look at how the application and the users engage with that application.
I have a question related to the ETL. What are the ETL tools that's compatible with Couchbase to move from one data store to another?
So we have the APIs that allow us to extract information. So we have customers that just batch processing tools. So in regards to the ETL, there are probably a lot of tools out there, but I'm not very familiar with them. I'm not an expert in that. But we do have customers that would actually develop their own wrappers, or they'll have tools that extract information from Couchbase and then put it into their basically the other systems. So if you want, I've got your information, so what I'll do, I'll ping you the right person to give you the ETL information from our teams. Is there any more questions? There's a question there.
I'm an accountant director, so technology is something that supplements my discipline. It's not the main.
My question is that if you have Oracle user, Oracle database user, and it's not a cheap investment, it's very expensive to invest. Now, in your booklet, you mentioned, the company booklet, it mentioned that you can complement the engagement database to your current transactional and analytic database. Now, as most of the customers, the trend, your customers are using this approach, like they complement. And if I go to your website, would I be able to find specific customers and with success stories that we can, explore the option and see how it's, complement. The other thing is, it says that it's the first world engagement database. Does that mean it's the only or just the first one?
So that's fine. So you have two questions. The first question is, do we have reference customers? And if you go to our website,
especially Oracle, like an Oracle, because I'm concerned about, and sorry to interrupt you, I'm concerned about two things: value for money, and then you don't want to have a messy transition. You need it to be the complexity of the whole exercise.
so yes, that's true. So we have lots of references from Oracle. Because of the time that we have today, there is examples like Apple, stuff like that have used Couchbase. And if you look at Apple ecosystem in 2013, we were the only NoSQL vendor in Apple. And what they've done in there, they had an Oracle statement. They had certain requirements for that. They wanted to actually use. So when you go to your iTunes stuff like you are using Couchbase, the biggest chance they had is that they wanted to move to a technology that can scale on demand, has the flexibility, and also reduces the cost. So you are right. When you invest in Oracle, you invest in quite a substantial amount of money. Probably talking, if you are in Exadata, probably millions of dollars and pounds. So what customers usually do is they go, well, we have this Oracle estate, but we can't afford to constantly invest in that because it's taking a lot of money. So what they do, for example, and we can talk about Emirates, and we can talk about PowerPower, and a lot of customers, they'll take a subset of that. They'll either have the Oracle systems, and they'll complement it with Couchbase, and they'll get the performance and confidence, and they'll gradually eat away from their Oracle and increase their Couchbase estate. And that's what you're seeing with Oracle, with Apple's estate. 80% of the Oracle estate for your iTunes, etc. interaction has been decommissioned using Couchbase. If you look at Emirates website and stuff like that, again, Emirates started very, very small, just to gain the confidence. And what's happened now, the entire system, is that they've got plans now for the next 3 to 4 years to start moving away from the Oracle decommission now and start using Couchbase. Because what you'll see now, you'll see customers looking for microservices basically on more interaction with the system. In order to do that, you have to have more customized systems. You need to be able to spin out a lot of servers and processes now. So you really look at the microservices aspect. What Emirates are doing is that they're moving in that area and a lot of other customers. So again, they're moving away from the Oracle estate and starting using Couchbase. If you look at Sky in the UK, again, they had Oracle. And the thing is with them, quite surprising, they had is as much as you want Oracle estate. They had a massive Oracle license. But it wasn't the actual developers, it was the customer saying to them, you're not performing well, you're not actually giving some services. So they had to decommission and start looking for other technologies. So for that, there's a number of examples. If you go to a website, you'll see PayPal, you'll see basically Viber, you'll see a lot of customers out there, LinkedIn. They'll tell you, I'm using Couchbase because it provides a very good service and also reduce the costs, greater performance, and a lot of customer experience. Has that addressed your question?
Yeah, thank you for the reference. Now, for the simplicity, you said there is a value for money and there is a reference customers that I can. Is it quite easy exercise to transition? What to expect during the transition?
So, if I said to you, yeah, it's just easy, you take a one and that's it, it's done, that I wouldn't be telling you the truth. So there is a transition where you have to move from relational to Couchbase. And that transition, the first time you need support to go through that transition. There's a lot of questions like fly Dubai, Ryanair. It requires the first step to actually move to them. So once you've actually done the transition, your data modeling from racial to NoSQL Couchbase, once you've got that confidence, then it becomes quite simple. The actual learning curve, if you've got Java development.net, the APIs are quite simple. It's just ensuring you're doing the data modeling correctly. So the first time, after that, it's straightforward to do from there.
Thank you.
I don't know if you have time, but I think if there's any more questions, or do you have? Oh, we don't have no time, so sorry about that. If you need me anything like that, please ask me. I'll be around. But I thank you, everyone. Thank you for staying behind. I really appreciate it. Thank you.
We want to thank you all for coming and for staying till the end. Please make sure to register for your certificate of attendance. And in the same registration, you can also check in for the option of a free data strategy consultancy meeting. And if you are interested in Couchbase itself, you can also register for the sandbox. So we will, Interkey will provide cloud already installed Couchbase server where you can play around with it, get to know the product a bit better. So please make sure to register. Thank you very much for being here.